Hello, I'm Alys and I'm delighted to have been asked to speak to you today about research software engineers and how we're working to establish this new role in UK academia. I'll be telling the story from my perspective in the UK, but I hope there's some common themes that will be recognisable to anybody working with software in a research context. We're excited about the momentum that's building up behind the research software engineer term, but clearly many people have been doing this work under a variety of job titles for a long time, and in fact this is part of the point. This talk is partly about the power of naming things and how that enables a community to form around a common experience. I'll give you an overview of what I'll be covering in this talk. First, I'll introduce myself and talk about my background and career so far and the work I do now. Next, I'll summarise the key problem in research software that motivated this movement in the UK. The middle part of the talk will tell the story of the progress that's been made over the last 5 years towards addressing the issue, and then I'll move on to a bit more detail about what we mean by a research software engineer, and I'll illustrate the points with some case studies to bring in the voices of some more members of the community. Towards the end, I'll highlight some of the activities going on at the moment, including quite a lot that's happening in other countries. And finally, I'll fire you up to change the world, or maybe just the provision of software expertise for modern research, with some inspiring closing remarks. Unfortunately, as I'm not there in person, I will have to imagine your rapturous response. So a bit about me to start with. I'm speaking to you from a small rainy island on the other side of the world. I think it's 9 AM for you, so I'm probably sitting at home with a cup of cocoa in the evening, hoping the video link will work later for the questions. I live in a town called Abingdon in the south of England, near Oxford. Abingdon is famous for a bizarre ritual where the mayor and town councillors throw buns from the roof of the town hall to mark special occasions like royal weddings. The whole town turns out to try and catch them, just like the 2 boys in the picture there. There is some more productive activity going on in the area, as several large science facilities are sited here. And I work at one of these, Culham Science Centre, which houses, amongst other things, a world-leading centre for nuclear fusion research. I'll tell you a bit about my background and my career so far. I've got a master's degree in physics from the University of Bristol, and following that some research experience in quantum information theory for my master's project, and then particle physics and cosmology as a postgraduate. I taught myself programming quite late on during my degree and postgraduate years, having initially thought it wasn't for me, until I realised it was necessary in my final year, and then finally found I really liked it. I moved on to work for the University of Oxford, doing mostly web development and information systems on a 2-year contract. After that I came to work at the UK Atomic Energy Authority in Culham, nearly 10 years ago now, to work as a software engineer on data systems and tools for experimental data. In 2014 I became leader of the team I had been working in, and now I have a remit to develop software engineering strategy and policy for the organisation, working with others on an internal working group I set up. In 2015 I started to get involved in the wider research software picture through a fellowship with the Software Sustainability Institute. This gave a small amount of funding for travel and events to promote improvements in research software via people embedded in particular domains. But more important than the money was the network of people who cared about the same issues that I did, and my involvement grew from there. For the last year I've been joint chair of the UK RSC Association, which is the focus of most of this talk. The UK Atomic Energy Authority is a government-sponsored research organisation, and our activities fall under several areas, as shown on this slide. The core of our work is the quest to develop nuclear fusion as power source. Culham Centre for Fusion Energy is the UK's national fusion laboratory, and this is the area that I've predominantly worked in. Now we're increasingly diversifying into other areas where we've developed expertise from our fusion work, such as robotics and automation and materials research. We are increasingly involved in commercial contracts as well as research grant funding. Many of these areas are strongly reliant on software, and it's getting more and more important that it's reliable and the results are reproducible. At Culham we have 2 experimental fusion reactors called tokamaks. These are large devices which use magnetic fields to confine the plasma where the fusion takes place. MAST is the UK experiment, part of the government-funded research programme. It's a spherical tokamak and it's currently being upgraded ready for a new series of experiments. JET is the Joint European Torus, operated at Culham on behalf of the European Commission. Scientists from many countries come to take part in experiments. JET is currently the world's largest fusion reactor and the only one that can operate with tritium and deuterium fuel, which is the planned reaction for future power plants. Plasmas inside JET reach temperatures 10 times hotter than the core of the Sun, making it the hottest place on Earth. JET's been running for a very long time, since 1983. Therefore, software sustainability and data management are extremely important. My group consists of 7 software engineers responsible for data systems and tools for the JET experimental data. In addition to developing and maintaining and supporting our own software, we sometimes collaborate with scientists on their research code. We provide advice and assistance and training on software development and data handling to people throughout the organisation. The tools my team develop cover the whole of the JET data pipeline. First, data from the many diagnostic instruments on JET is stored in our raw data system. Then a suite of analysis codes process the data to reconstruct physical quantities. Thousands of separate signals are stored for every experimental run or pulse. We provide tools to let scientists and engineers discover the data of interest to them and retrieve it for further analysis. They access the data via APIs, which abstract away the underlying storage, and part of the work we're doing now is to consolidate several data sources that are accessed in different ways for historical reasons behind a more modern unified API. Finally, we provide visualization tools used to keep track of live data during an experiment and for offline analysis later. So why is software in research a particular issue? Well, I'm sure I don't need to tell anybody here that software is crucial for modern research. In the UK, the Software Sustainability Institute did a survey of researchers and found that 92% of them use software in their research. 69% said that the software is fundamental to their research results, and over 56% develop their own code. So we would all like research software to follow the 3 Rs, to be reusable, readable and reliable, which sounds really simple, but getting there often seems difficult. Why is that? Well, making good software can be hard in any context, but in the academic world, there are also structural and cultural barriers. Often it's simply nobody's job to focus on the quality of the software. You can think of people who write software in research as lying somewhere along this spectrum, from pure software engineers at one end to pure researchers at the other end who don't write any code. The traditional researcher-developer in an academic research group might lie over there towards the right, but there's often rather a gap in this spectrum for people who are focused on the software but also still understand the research. Plenty of researchers can write good code, but it simply isn't the main focus of their career. In fact, the career structure and research metrics actively penalise them for time spent focusing on software rather than focusing on getting the next paper written. So this is where the research software engineer comes in. The role refers to this place right in the middle of the spectrum. So these research software engineers are people who combine software engineering skills with an intricate understanding of research to really be able to bridge that gap between the two worlds. Software experts who also understand research can be found in many roles in research organisations. Often there might be people in research IT departments or teams in HPC centres. National labs in large facilities are often more likely to have such roles employed under permanent contracts. but a huge amount of the software expertise is hidden in roles that are labelled as postdocs or junior researchers. Sometimes these people have spent a lot of time honing their software skills, often at the expense of their academic career. Yet they perform this hugely valuable role in the research group, and often everybody turns to them for help, and indeed the research would not be as productive without them. Another interesting piece of research from the Software Sustainability Institute looked at 10,000 job adverts on the main UK academic jobs site called jobs.ac.uk. About 400 of these related to software development in some way or another. And they were listed under 194 different job titles. The lack of recognised names for this crucial role leaves those trying to carve out a career path without a clear structure to navigate, and often lacking proper recognition and influence. Ultimately, this harms research, because the lack of career path increases the risk of losing these vital skills to other sectors. Now I'm going to tell you the history of research software engineers in the UK. This material borrows heavily from the writings of Simon Hetrick, and I can really recommend following the reference at the end to his blog post on this topic. So to start, let me take you back through the mists of time to 2010, when the term research software engineer was yet to be born. RSE prehistory, if you will. The Software Sustainability Institute was established then as a collaboration between 4 leading UK universities to focus on enabling better software to produce better research. The SSI has a focus on community building to magnify their efforts, and I've already mentioned how it was their fellowship programme that first got me involved in the National Research Software initiatives. And it was this community building work that brought together the people that sparked this new movement. The SSI organises an annual collaborations workshop, and in 2012 it was held in Oxford. At this workshop, James Hetherington described something he saw as a crucial requirement for improving the state of research software. He said, developing the profession of a scientific software engineer and the career track of software developers in academia. And it was at this point that the term research software engineer was coined and adopted by the people present to describe this crucial but overlooked role in research. Later in the same year, the first University Research Software Group was established at University College in London. This is where a team of research software engineers are available for collaboration with academics from all disciplines, and it's a new model of organising software expertise within a university. There are lots of advantages to consolidating this expertise in a central group, both for the RSCs themselves, who benefit from working in a team with other software specialists, but also for the institution, because it increases access to these vital software skills for research teams who couldn't fund a dedicated post for themselves. Another benefit of a central group is to act as a hub for research software engineers embedded in research groups and researchers who need to acquire programming skills. The group can provide teaching, training, and a focus for the software development community in the university. In the intervening time, there was lots of publicity for the new RSE concept and some popular blog posts and articles that got a lot of views. And then in 2013, a workshop was arranged to bring together research software engineers in Oxford. The suggestion was made of starting a community to represent RSEs and to work to improve access to their skills, and this was met with enthusiasm, and an initial group formed to start the community. The UK RSC Association was launched in early 2014, and it gained 160 members within the first 3 months. Later on in 2014, this initial founding group handed over control to a committee that was elected by the members, so the UK RSC Association became democratic. In the meantime, the term research software engineer was gaining a lot of traction and becoming widely recognised both by research organisations and even funding councils. It was also popular amongst the people writing research software, with whom it clearly struck a chord, and people began adopting the job title. The tweet shown on the right is an RSC who hadn't previously been formally involved with the organisation, proudly announcing that he'd changed his official job title. In 2015, there was another milestone when the UK Funding Agency for Engineering and the Physical Sciences, EPSRC, announced that they were putting out a call for people to apply for a dedicated RSE fellowship. This was a prestigious award with 5 years of funding for 2 staff members, and it was designed to kickstart the establishment of further research software groups. 211 people applied for what was originally planned to be 3 places, and in the end 7 RSE fellowships were awarded. You can hear about the impact one of these fellowships had on the career of the person who received it later on in our case studies section. Over the next couple of years, the UK RSC Association continued to grow steadily as more people heard about it. It's an inclusive community. Anyone who identifies themselves as doing the work of an RSC can join, no matter what their official job title. At the same time, more research software groups were being founded in universities and research institutes, inspired by the UCL example, but adopting various organisational models and funding structures to suit the needs of their institution. With all this rapid growth going on, there was a real need for more coordination. We were able to get a small network grant that lets us employ a part-time community coordinator, Claire Wyatt. Having Claire to take an overview of our activities, meetings and events, and keep everything on track has let us do much more with the effort of all these enthusiastic members who commit their time around their day jobs. With the expansion of research software groups, the new RSE fellows, and the identification of teams of pre-existing RSEs in national labs and research institutes, there was a real desire for the people in leadership positions to share their knowledge and experiences with each other and coordinate their activities. So the Research Software Engineering Leaders Forum was established, who meet twice a year and have an active discussion group. This is not only for people who are already leading research software groups, but it provides essential moral support for people who are doing the difficult work of trying to establish new groups where they don't already exist. The moral support element of this network is really essential. In the past, UK RSE had held annual general meetings and one-off workshops, but last September we organised the first ever conference specifically for research software engineers. This felt like a real milestone and a demonstration of the vitality of the community. A new committee was elected at last year's conference, and we've been busy over the last year. I'll speak more about the activities we're doing at the moment in the last part of the talk, but one of the first things we did was establish a new website and use of Slack for discussions, and this has been very successful and there's a lot of activity on there. Our Slack channel is open to people from anywhere as well, not just UK-based RSEs. So, having laid out how the RSE movement in the UK began and some of the progress over the last few years, let's take a closer look at the work of an RSE. So what do RSEs do? Of course they write code, but a person who combines software expertise and an understanding of research is a very useful person to have around. And in fact, RSEs do all of the things on this list and more. Obviously, a given individual RSE is likely to focus on a subset of these, but research software groups might aspire to cover most of them amongst a team. The ways RSEs can help research range from specialist technical services like optimising code and making it run on HPC systems, to activities that are generally more associated with academics, such as university teaching and contributing to papers. There's a strong emphasis on establishing good programming practices and encouraging clear, well-structured code. That's because this is a key prerequisite for all sorts of other good things, such as ensuring the results are correct and can be reproduced, and making software useful to groups elsewhere, as well as making it easy to improve and extend. So what skills do RSCs need to achieve all of these good things? Well, when they were asked, this was the result. Communication and programming are the most common answers, notably in that order. RSCs are often the bridge between groups of people with very different perspectives and have to be great at explaining things in a way each group can relate to. Getting a good technical result is usually dependent on a whole lot of careful communication and often a healthy dose of persuasion. Also, you might note that patience is in there. Now I'm going to present some case studies of real projects and real RSC careers. As well as illustrating lots of the ideas I've been talking about, there's the added advantage of giving you a break from listening to my voice over slides, as some of the people involved have been kind enough to record short clips of themselves talking about their work in their own words. Firstly, we have two examples of projects from very different research domains. Eleanor Robson, a lecturer in ancient history at University College London, came to their research software group with a problem. She had a project which involved transcribing and annotating ancient Babylonian cuneiform tablets. They already had an electronic system for doing this, but it was difficult to use and required online access to validate the file that was being edited. An RSE from UCL's group was hired to define a lexical grammar for the file format and to make a new user-friendly interface. There are two main points that can be drawn from this example. One is that Eleanor Robson wouldn't have got funding to hire a full-time programmer for her own group, and a traditional software engineer might have struggled to adapt to Babylonian. The second is that programming tasks exist in unexpected places, and a dedicated research software group can be flexible enough to provide people to fulfil the tasks. The next project case study involves an RSE from my own group at Culham, working with a physicist who is confident developing his own code, but sometimes wants to bring in an expert for particular aspects of the project.
So hello, I'm Matthew Carr, working at the UK Atomic Energy Authority. I work here in the experiments department with hot plasma diagnostics, where we use the light coming off the plasma to infer things like the plasma temperature and how efficiently the reactor is running. And here we've developed some very sophisticated ray tracing software for simulating and also diagnosing this sort of diagnostic data. As professional scientists, we're not trained with a software background, so we tend to learn software programming on the job. So we've found that in our project it's very helpful to be paired with an RSC because the RSC can provide very targeted help on things like cleaning up the structure of the code, making it much faster, and in general just making the project much more professional for sharing with the outside world. Our project was quite successful, and we're now expecting it to be open sourced and installed in a number of labs around the world, and I think having an RSC involved has particularly benefited this process.
Now, three RSCs at different stages of their careers will give us their own perspectives on the role. First, Robert Haynes, who's been involved in the UK RSC movement from the beginning and now runs a research software group.
Hi. My name is Rob Haynes and I lead the Research Software Engineering Group at the University of Manchester. I did a degree in computer science here in Manchester and then stayed at the university getting a job in the Manchester Visualisation Centre. I was attracted to academic software engineering by the promise of varied and interesting work. I was always called a research assistant, but my work was dominated by writing software, not writing papers. Over the next few years, I worked on a range of projects and noticed real variation in how software experts are treated in research. A lot of these projects won awards and publications in top journals, but we were sometimes not acknowledged. Thankfully, some projects took a more inclusive approach and treated us as part of the team. Working for these projects became very attractive. I have been involved in the RSC campaign from the start in 2012. I was part of the workshop where the term Research Software Engineer was coined, and I started using that instead of my formal job title from then on. I've been on the UK RSC committee since 2014, and last year I was chair of the first ever RSC conference here in Manchester. In 2015, I established the Research Software Engineering team as part of Research IT within IT Services. We work on projects with researchers, support research applications, and provide teaching and training in software engineering. Our projects range from 5 minutes to get your code working to 5 years, embed an RSC in your research group. The group is now up to 15 people and we're expanding again this year. The reason I think RSCs are so vital for research is that we care about the correctness of science through the reproducibility of code and about sustaining software so that it lives beyond a single paper publication. Research software engineering groups are important because they make our skills available to all researchers, not just those that can afford to hire a full-time RSC.
Tanya Allard is a junior research software engineer in the research software group at Sheffield University. She recently completed her PhD in materials science, where she encountered many of the problems associated with poorly written and documented academic software. For an early career researcher, deciding to move into full-time research software engineering was something of a leap of faith, because the lack of typical academic metrics could make it difficult to return to a traditional academic career. The UK RSC movement is working to make sure there's a network of suitable positions and associated career structure for talented people like Tanya.
Hi, my name is Tanya and I work as a research software engineer at the University of Sheffield. And the reason for me to pursue this career is that over the course of my PhD I realized how important research software is, and more important, how crucial it is that this software is sustainable, reproducible, and developed according to best practices. This ensures that the software is not only usable, but that will foster open research and reproducibility, and will also enhance the accuracy and the confidence in the results published.
Our final case study is Louise Brown from the University of Nottingham, who's been a software engineer for about 25 years on various projects in academia and for companies.
I returned to academia after about a 20-year gap and had applied for a position as a software engineer and got the job. And when I started, I found that I was actually employed as a research fellow, and that was okay to start with. I just got on with the job, but as time went on, it became apparent that that was problematic from a career progression point of view. There was nowhere for me to go, really. I didn't have a significant publications record, especially not recently. And as my performance reviewer put it, I didn't fit the standard money in, papers out model for a researcher. When I saw the EPSRC Research Software Engineering call, that seemed to sum up my situation. And so I applied for one of those, and much to my continuing astonishment actually got one. And that got me through the promotion thing, because at Nottingham there's a route for promotion to senior research fellow for people with personal fellowships. So things have improved. The situation's still not perfect because there's not a huge awareness of the research software engineer role at Nottingham, but we've been working on raising awareness, and now there seems to be a commitment to start an RSC service. We're not sure exactly what that will look like, or indeed what my role in that will be, but things are moving and there is a commitment in that direction. We've also started a research software network just a couple of weeks ago, and there were 30 people came along, and there's quite a lot of enthusiasm to engage with that and move things forward. So really at Nottingham it's a case of watch this space.
As I mentioned before, it's been a busy year for the UK RSC Association this year, so I'll just talk about a few of the major activities we've been up to over the last 12 months. A real highlight of the last year was the first ever RSE conference, held in the Manchester Museum of Science and Industry last September. Over 200 RSEs got together in one place for talks, technical workshops, and of course plenty of opportunities to exchange experiences and meet each other. The response was really positive, and there was quite a buzz in the air. When RSEs come to an event like this for the first time, there's often a real sense of recognition and of people finding others who share their perspective. This year's conference is going to be held in the same venue in September, and it's already sold out many weeks in advance, so we're looking into bigger venues for 2018. To help us know where to focus our efforts and to make better arguments to the people with the power to change things, we wanted to know more about RSCs in the UK, who they are and what kind of work they're doing. So the SSI ran a survey of RSCs last year, sent to all the members of our mailing list. And I'll just present a few of the key findings here to give you a flavour. It shows that RSCs do indeed have an intricate knowledge of research, as claimed, with over 2/3 of them having a PhD and 88% of them having contributed to a paper. Only 11% of RSCs surveyed were female. What you can see here is the percentage of female representation in various subjects at undergraduate level. The RSE population is less balanced than any undergraduate subject. This could be explained by the fact that in the UK, most RSEs come from physics and maths backgrounds, which are known to be very unbalanced, and also most have a PhD in these subjects, and these subjects are known to get more imbalance beyond undergraduate level. As a community, we're committed to being open about our gender balance issues and working to increase female participation in all our activities. We are having some success with this. 18% of people who came to our conference were female, and 3 out of 10 of the members of our current committee are. We're also paying some attention to the way job descriptions are written, and the RSE Leaders Group are hoping to issue some guidance in these areas. The hope is that these short-term actions will have some effect in the long term on the makeup of the community. Research software can be particularly vulnerable to becoming unmaintainable due to the departure of key staff. Research software engineers were asked for 2 different metrics relating to this in the survey. One was the bus factor, i.e. how many developers would have to be hit by a bus before the project fails, and the other was relating to the presence of technical handover plans, some documentation to help a new developer get up to speed. The results were concerning, with 46% of respondents working on a project with a bus factor of only 1, and 78% of them working on a project with no technical handover plan. The plan is to repeat this survey of RSEs every year to get some idea about how things are changing over time. This year, the UK survey has already been run and the data is currently being analysed. And it's also been shared with collaborators in other countries, and the Canadians have already run a survey. Some early results of this already show intriguing differences between the results from the UK and Canada. The plots on the screen show that in the UK, most RSEs come from a background in physical and mathematical sciences and computer science. But in Canada, the distribution looks very different, with nearly half of the respondents being in the other category. I can't hazard a guess as to what these results mean just yet, but it's just a glimpse that we might find some interesting findings from comparing the situation in different countries. Something that doesn't make for exciting slide content, but has actually taken up a lot of effort this year, is that we're working towards setting ourselves up as an independent organisation with the ability to handle our own finances and enter into contracts independently. Part of this process involves defining a proper system of governance laid out in a constitution. Another big theme this year has been ever-increasing levels of interaction with people from other countries involved in research software. Last year's conference had participants from 14 different countries, and it was great to meet people from elsewhere who care about the same issues to compare notes. The conference was co-located with WSPI, a workshop that usually runs in America, so we had quite a few Americans, but also Canadians, people from many different European countries, and even representation from New Zealand. This year we're hoping for an even wider spread of nationalities, and are running a dedicated international RSC discussion workshop to allow us all to compare notes. Some German RSCs who'd been involved in the UK RSC community and came to our conference decided to start a German RSE network, and DE-RSE was established soon afterwards. It now has its own mailing list, Slack platform and website. A few months later, we heard from Niels Drost, who sent the following email. Following inspirational visits to RSE 16, SSI events and encounters with UK RSE and DE RSE members, a small group of engineers at the Netherlands eScience Centre has been planning to start a Dutch equivalent for some time now. So without further ado, introducing NLRSE. The German and Netherlands RSE organisations have agreed to have a representative co-organising our international RSE workshop at this year's conference, and we really hope this might kickstart RSC associations in further countries. And on that topic, we were very excited to hear a couple of weeks ago that there is now an effort underway to start an RSE chapter for Australia and New Zealand. A group of 8 people listed on the slide have come together to get started, and many of them are associated with national level infrastructure or e-research facilities. Manadeep Sinha tells me that they will be circulating a short survey to gather expressions of interest soon, but if anyone is particularly keen to get started, they could get in touch with him. I noticed that one of the organisers of this conference, Alexandra, is involved, so perhaps you can find out more from her. So to finish off, I just want to draw out a few thoughts about what I've learned from my involvement with the research software engineers community. And I think much of this applies to all sorts of situations where you might be trying to change an established way of doing things. One lesson I've learned is the importance of picking what's relevant when listening to the experience of others and not getting too hung up on areas which don't chime with your experience. Whilst it seems to be the case that a lot of the issues I've talked about are common for a wide swathe of research software developers, there are also many differences depending on context. Even taking the name, some countries would have trouble adopting research software engineer as a job title because engineer is a restricted title requiring particular qualifications. To take another example, RSEs in government labs often have quite a different situation in relation to funding from RSEs in universities. It takes some thought to reframe what you hear in your head to see what's relevant in your country, your research domain, your type of organisation or your type of role. Another important point is that when you want to change something that you encounter in the world, action can be taken on all scales and it's important on all scales. Individual involvement in a community, the way you do your job and the way you interact with your group and your peers, can help promote a change. Getting involved in local networks within organisations or regions can be very valuable. And then also joining together these local networks into a national picture and making links on an international scale are equally important. It's not easy trying to change long-established ways of doing things. In particular, academic funding and administration is not particularly known for its agility, and there's a lot invested in the system as it stands. There will be resistance to new ways of doing things, and we should expect it and be prepared to keep going anyway. So change is not easy, but small changes do add up. It's said that people tend to overestimate what they can achieve in 1 year, but vastly underestimate what they can achieve in 5. We win some battles and lose some, but if we keep making progress, we will get there in the end. Luckily for us, communities are powerful. We need the support and different perspectives of each other to make progress. When we're trying to do hard things for good reasons, moral support is just as important as any other type of help, and this is a powerful way communities can create change. In my experience, there are many research software engineers who are smart and determined and motivated and who know how to work together, so I think the odds are in our favour.